Here we're going to analyze the geometric interpretation of a derivative. In this figure here we are representing the function y as a function of x. Let's consider that this blue line here is this function y as a function of x, and we want to see what's the geometric interpretation of the derivative of this function here evaluated at point x naught here. So first let's consider some preliminary information that we need to analyze before going for the geometric interpretation of the derivative. So if we are at this point x naught, so the value of the function y evaluated at this point is this one here, okay, this one, and this we're going to represent that by y naught, which is the value of the y function evaluated at x0 here. Okay, this is one thing. And if we go from this point to this other nearby point, considering displacement on x of delta x here, so therefore now we do have a point which is located at x0 plus delta x. The value of the y function evaluated at this point here is going to be that one here. This is the value, and we're going to represent that by y0 plus delta y, which is actually the value of the y function evaluated at x0 plus delta x. Therefore, we do have that the change on y going from one point to the other is this one, while the change on x when going from one point to the other is delta x here. So as you can see here, this is the triangle, the square triangle that's formed here, and the hypotenuse is this green line. And this, if we elongate this green line here, that's going to be the line which actually is going to cut. As you can see here, cuts the function here. And this green line is forming an alpha angle, which actually is going to be the same as this one, with the positive direction of the x-axis. And actually this tangent, trigonometric tangent of the alpha angle is delta y over delta x. Now, considering that, now it's important to go to the definition of the derivative. Okay, that's the definition of the derivative here. This is the definition of the derivative. So, the derivative of the y function with respect to x evaluated at x0 is actually delta y, this is delta y, you can see, over delta x when we're making delta x going to 0. So as you can see here, as you can write it this way, it's a limit when delta x goes to 0 of delta y over delta x. So as you can see here, it's going to be the limit when delta x going to 0 of this tangent alpha. But in this case, when we're making the delta x going to 0, so the line that we are going to have, it's no longer going to cut the function, because as you can see, when we are making delta x going to 0, the nearby point that we have to consider has to be very close to the x0 point, which is going to be this one, for example. And in this case, the y point is going to be evaluated corresponding to the x point, which is very close to the x0, is going to be that one. So in this case, you can see here that the triangle that will be forming when delta x is going to be 0, it's going to be very small, and actually the hypotenuse is going to be over on the line corresponding to the function. So in this case, the hypotenuse, if we connect or extend the hypotenuse line, will correspond to the tangent, to the geometric tangent. So in this case, the green line now, when making delta x going to 0, is going to be a geometric tangent to the function at point x0. And the definition of the derivative in this case, this geometric tangent is going to form, in this case, a beta angle, for example, with the positive direction of the x-axis, and therefore, in this case, the derivative, the geometric interpretation of the derivative of this function evaluated at this point x naught is going to be the geometric tangent of the angle beta, where the beta angle is constructed in this way. It's constructed just by making the geometric tangent to this function at point x0. And this geometric tangent, the angle that this geometric tangent is forming with the positive direction of the x-axis, in this case we are calling it beta, uh, the tangent of this beta is actually the uh, the derivative of y function evaluated at x0. That's actually the geometric interpretation of the derivative. That's going to be quite useful when dealing with numerical methods.